Hello everyone, today's geometry lesson is on finding the volume of a prism. And I have three examples for you, but in each example I'm going to start with the general formula for volume of prism, which I already have on the screen. Volume equals capital B times capital H, base times height. We'll go over that in a second. Many of you have probably already identified that this is a rectangular prism. And you may even already know that the formula for rectangular prisms or cubes is length times width times height. And you would be correct. But again, the focus of this is to start with the general formula for volume of a prism, because this will help you on every type of prism. So going back to the general formula, capital B, if you notice it's a capital B, and there's a reason for that. When we were doing area of two-dimensional shapes, we were using lowercase b's and lowercase h's, and you will see that again in other examples. But this is a capital B for a reason. It's representing the area of the base shape of our prism. So the base shape of our prism, and I colored it in pink here, is a rectangle. So this capital B is representing the area of the base shape, the rectangle. This capital H isn't just height, but it's the height of the entire prism. So height of prism. And something to keep in mind, even though I'm using an H, here we can see the height of this rectangular prism is 5. It's 5 centimeters. But there are times where the prism might not be standing straight up and down, so it won't really be the height, it'll be the length. And again, you'll see that in a later example. But let's go back to our formula here. So volume equals capital B. Well, we already said capital B is the base shape, which is a rectangle. So in parentheses, I'm going to put the formula for area of a rectangle, which we already said in a previous lesson is length times width. And then on the outside of the parentheses, the capital H for the height of our entire prism. Now let's plug in the numbers. The length of our base rectangle is 15. The width of our base rectangle was 8. And again, on the outside, the height, which is 5. And you can see this is the same formula. It's length times width times height. But again, the purpose of this is why the general formula. So 15 times 8 inside the parenthesis is 120 times 5. Then 120 times 5 gives us 600. Now remember, volume is always cubed, centimeters cubed. And if you're not 100% sure why it's centimeters cubed or cubed centimeters, remember we multiplied these three numbers together. Well, we also multiplied together centimeters times centimeters times centimeters. Well, how could you rewrite this so people know you multiplied centimeters 3 times? It's centimeters cubed. So that's where that's coming from. Let's look at our second example. All right, we have a triangular prism, and you can see I colored my triangle in green. Now, the formula, the general formula is capital B times capital H. Let's rewrite what we know. The base shape of this prism is a triangle. So let's put the formula for area of a triangle. Remember, that's what the capital B is representing. So area of a triangle is 1/2 times little b times a little h, right? The base of the triangle and the height of the triangle on the outside is the height of the entire prism. Well, this is what I was talking about on the previous example. This thing looks like it's sitting down. It's not standing. The prism's not standing straight up and down. So this doesn't really look like the height, but because it's one of the rectangular sides, it is the length of the prism. So sometimes you're looking for the length of the prism, not necessarily the height, depending on how it's standing up or sitting down. Either way, it's still going to be the height of the actual prism. So let's plug in some numbers. In parentheses, I have 1/2 times the base, which was 7, times the height of the triangle, which was 10, times the entire height, or in this case, length of the prism, which is 8. Inside parentheses now, 1/2 times 7 times 10 gives us 35. On the outside, times 8. Multiply those two together, and we get 280, and again, centimeters cubed. All right, last example for this lesson. Now, here's why the general formula is so important. First, what kind of shape is this? Obviously, it's a prism, but what kind of prism? Let's see if you recall how they're named. And that's why I have this covered up here. Let me get this. Hopefully, you said it's a hexagonal prism. So in this lesson, I'm not going to show you how to find the area of a hexagon. It's much more complicated than a rectangle or a triangle. However, as long as we know the area of our base shape, we just have to multiply by height. So let me just write down again, this was a hexagonal prism. Now over here, volume equals the area of the base shape, which they already gave us. The area of the hexagon is 120. So I just have to write 120 times the height of the actual prism, which is 11. Multiply the two together and I get 1,320 cubic inches, or inches cubed. And that's it for the lesson.